Myself Mary Hexy from the Department of Applied Electronics and Instrumentation. So I am handling AE 303 electrical measurements and measuring instruments. So this is the description of the module 1. In the module 1, we have to study the general principles of measurements. In that, the absolutes and the working standard, the calibration of meters, the qualities of measurements like accuracy, precision, sensitivity, resolution, then the loading effect, the character and its characteristics, and the last one is error in the measurement and its analysis. We need to familiar with the term measurement and instrument. The measurement is the process of associating numbers with physical quantities and phenomena. And in terms of instrument, it is a device or a system in which is designed to maintain a functional relationship between the prescribed properties of the physical variables being measured. Scientists, engineers, and other humans use a vast range of instruments to perform their measurements. These instruments may range from simple objects such as a ruler scale and stopwatch to electron microscope and particle accelerators. It provides the means of communication to human observer or the operator of the machine or equipment. The above stated functional relationship remains valid only when the static calibration of the system remains constant. The performance of the instrument of a system is usually described in terms of a set of static and dynamic characteristics. Before studying the measurement system, we will study the basic block diagram of the functional elements of the measurement system or the instrument. Okay, so this is the basic block diagram, and in this block diagram you can see that the quantity to be measured is given to the primary sensing element. Okay, so in the primary sensing element we will have the sensors. Okay, so the sensor will acquire the signal from the quantity to be measured, and the output of the primary sensing element is given to the data conditioning element. So this data conditioning element consists of the two blocks, that is the variable conversion element and the variable manipulation element. Okay, so the output from this data conditioning element then move on to the data transmission element, and from there it is given to the data storage and the playback element, and from there it is given to the data presentation element. So the raw data which is given at the primary sensing element, you are getting a processed data at the observer side. We will see each block in details. That is, the first block is the primary sensing element. Then the second one is variable conversion element, variable manipulation element, then the signal conditioning element, data transmission element, and the data representation element. So we will see each block in detail. The first one is the primary sensing element. Okay, the quantity or the variable which is being measured make its first contact with the primary sensing element of the measurement system. Okay, and the measurement is thus first dictated by the primary sensor or a detector. Variable conversion element. The output signal from the primary sensing element may be of any kind. That can be electrical signal or the non-electrical signal. So it could be the mechanical or electrical signal. It may be a deflection of the members of the some electrical parameter such as voltage, frequency, etc. Sometimes the output from the transducer is not suited to the measurement system. For the instrument to perform the desired function, it may be necessary to convert this output signal from the transducer to some other suitable form while preserving the information content of the original signal. Suppose the output from the sensing element is in the form of the very small displacement which is difficult to measure mechanically. It is converted into the corresponding electron with the help of a transducer called strain gauge for further processing. Also, if the output at one stage is analogous form and the next stage of the system accepts the input signal only in digital form, in such cases we will have to use a analog to digital converter. The third element is variable manipulation element. The variable manipulation means a change in the numerical value of the signal. The function of the variable manipulation element is to manipulate the signal presented to this element while preserving the original nature of the signal. For example, a voltage amplifier acts as a variable manipulation element. Here, the amplification is carried out. The amplifier acts as a small voltage signal as input and produces an output signal which is also voltage but of greater magnitude. The variable manipulation element could be either placed after the variable conversion element or it may precede the variable conversion element. After the variable manipulation element, we have the signal conditioning element. Many transducers develop usually a voltage or some kind of electrical signal, and quite often signal developed is of very low voltage, maybe of the order of millivolts, for example thermocouple, as you know. This signal could be contaminated by unwanted signals like noise due to an extraneous source which may interfere with the original output signal. Another problem is that the signal could be distorted by processing the equipment itself. If the signal after being sensed contain unwanted contamination of or the distortion, there is a need to improve the inferring noise sources before its transmission to the next stage. Otherwise, we may get highly distorted results which are far from its true value. The solution to this problem is to convert or remove the signal contamination or distortion. The operation performed on the signal to remove the signal contamination or distortion is called the signal. The term signal conditioning include many other functions in addition to the variable conversion and variable manipulation. Many signal conditioning processes may be linear, such as amplification, attenuation, integration, differentiation, addition and subtraction. Some may be non-linear processes such as modulation, filtering, clipping, etc. The signal conditioning processes are performed on the signal to bring it to the desired form for further transmission to the next stage in the system. The signal that perform this function may in any instrument or instrumentation system is known as the signal conditioning element. Next one is the data transmission element. There are several situations where elements of an instrument are actually physically separated. In such situation, it became necessary to transmit data from one element to other. The signal conditioning and transmission stage is commonly known as intermediate stage. The element that performs this function is called the data transmission element. For example, satellites or the aeroplanes are physically separated from the control station at the Earth. For guiding the movement of the satellite or the aeroplanes, the control stations send the radios signal by complicated telemetry system. And the last stage is the data presentation element. The function of the data presentation element is to convey the information about the quality or about the quantity under measurement to the personnel handling the instrument or the system for monitoring, control or analysis purpose. In case data is to be monitored, visual display devices are used. These devices may be analogous or digital indicating instrument like ammeter, voltmeter, etc. In case of the data to be recorded, recorders like magnetic tape, high-speed camera and TV equipments, the storage type CRT printer, analogous and digital computers may be used. For control and analysis purpose, control and computer elements are used. Final stage in the measurement system is known as the terminating stage. Absolute and working standards. A standard is a physical representation of a unit of measurement. A unit is realized by the reference to an arbitrary material standard or to natural phenomena including physical and atomic constant. The unit of mass is represented by a material standard, which is an example, the mass of the international prototype of the kilogram, consisting of platinum-iridium alloy cylinder preserved at International Bureau of Weights and Measures near Paris. You can see the prototype which is kept at Paris. That is the international prototype of kilogram. Different types of standards of measurements are the international standard, the primary standard, secondary standard and working standard. We will study each standards in detail. In which the first one is the international standard. It is defined by the international agreement. It represents certain unit of measurement to the closest possibility accuracy that the production and the measurement technology allow. Periodically evaluated and checked by the absolute measurement in terms of fundamental unit. These standards are maintained at International Bureau of Weights and Measures. It is not available to the ordinary user of measuring instrument for the purpose of comparison. So this is about the international standard. After the international standard, we have primary standard and it is maintained by the national standard laboratories in different parts of the world. The primary standards are not available to the users outside the national laboratory. The main function is the verification and calibration of the secondary standard. Secondary standard. It is the basic reference standard used in industrial measurement laboratory. The standards are maintained by the person involved in the industry and are checked locally against other reference standards in the area. Secondary standards are generally sent to the National Standard Laboratory on periodic basis for calibration and comparison against the primary standard. They are then returned to the industrial user with the certification of their measured value in terms of the primary standard. Working standard. It is the principal tool of the measurement laboratory. It is used to check and calibrate general laboratory instruments for accuracy and performance.